Hello everybody, this is lesson 9 of the lecture Macroeconomics. I will discuss the slides 1 to 43 of chapter 3, the neoclassical model. Before we start, let me give you an overview of this chapter. In this chapter we will discuss the neoclassical textbook model of a macroeconomy. In section 3.1 we will develop the structure of this model. As we will see, this macro model is based on the simplifying assumption that the major processes in an economy can be analyzed by the interaction between three markets: an aggregated market for goods and services, an aggregated credit market, and an aggregated labor market. In section 3.2 we will use this market structure to analyze the monetary policy of the central bank, fiscal spending by the government, and the consequences of random demand and supply side shocks which hit economies from time to time. So let's first have a look at the structure of the neoclassical model. The history of neoclassical theory reaches back to the beginnings of economics as an independent science. The formation of neoclassical theory cannot be attributed to a single person, like the Keynesian theory, which has been developed by John Maynard Keynes, as we will see in chapter 4. Neoclassical theory has emerged over the centuries and embraces the ideas about the working mechanisms of a market economy of several generations of economists. Common for all these economists is the attempt to explain why a market economy does not lead to complete chaos and disorder, but to a quite stable system. The intellectual counterparts of the neoclassical economists had been the so-called mercantilists, who, by and large, distrusted a free market economy and called for government interventions to steer the economy even at the industry level. The founder fathers of neoclassical theory can be subdivided in two groups. The classics in the 18th and 19th century, like Adam Smith, perhaps the most famous and prominent neoclassic economist, Jean-Baptiste Say, and David Ricardo. Following the classics, a market economy is sufficiently stable in itself. Government interventions in markets are therefore not necessary. For this very market-oriented doctrine, the catchphrase laissez-faire economy is typically used. According to the classics, short-run economic fluctuations may happen, but a market economy always finds its way back to the equilibrium without government interventions. The other group of founder fathers are called the neoclassics at the end of the 19th century. Most prominent members of this group have been Léon Walras, Irving Fisher, and Arthur Pigou. The neoclassics shared most ideas of the classics, but saw typically a government task in the establishment of a framework for the functioning of markets. They especially attributed the care for sufficient supply of public goods to the government. Like the classics, however, they rejected government interventions to steer, for example, business cycles. Now, let's have a closer look to the structure of the neoclassical model. In the following, we will develop the simplest form of a neoclassical model. This model will contain the circular flow model as a basic feature. It consists of three markets, as already mentioned: the labor market, the capital or credit market, and the market for goods and services. The circular flow representation of this model is demonstrated by the following graph. On one side of the economy we have, once again, private companies, the firm sector. They supply goods and services to the market for goods and services. On the other side of the economy we have the household sector, and they basically demand these goods as consumption goods. Part of the production of firms are investment goods which flow back to the company sector itself. Households supply their labor services to the labor market and their savings to the capital market. On these markets appear now the firms and demand labor for the production of goods and capital to buy investment goods. Now we have to take care also for the government, which is symbolized here as an eagle. The government buys goods on the goods market and finances these expenditures with money it levies in terms of taxes on households, and if tax income is not large enough to finance all government spending, the government goes to the capital market like the firms and demand a credit there. So we have the government and the firms on the demand side of the capital market and the households on the supply side. Now, big question is, where does the money come with which all these transactions are paid? Here we have to introduce now the central bank. Modern central bank, like the European Central Bank, supply their money in normal times in terms of credit to the capital market. So now the central bank appears on the supply side of the capital market, side on side with households, and offers their money as a credit. This money is demanded by firms. Firms use this money then to make their payments for labor and capital to households. So this money flows to households. Households use then this money to pay their taxes to the government and to finance their purchases of consumption goods. The part of their money that is not consumed or paid to the government is used as savings and offered on the capital market as credits. So now we have again a closed model a circular flow that explains how economic activities within one period of time, typically 1 year, is undertaken. Now, we have, of course, to develop again a much more detailed version of the neoclassical economy that can give us answers to questions like how does monetary policy affect the economy, how does fiscal spending policy by the government affect the economy, and how do economic supply or demand side shocks affect the economy. To do this, we have to develop a model that has a little bit more formal structure. The standard textbook version of the neoclassical theory is based on a couple of important assumptions. And before we develop this model, I would like to explain these assumptions. First important assumption is that all prices in the economy are perfectly flexible. Wages, interest rates, goods prices react immediately if demand and or supply changes. As a result, disturbances of the general market equilibrium do not persist. After a shock, the economy finds immediately back to a general market equilibrium. This is the fundamental difference between the neoclassical and the Keynesian model. The price adjustment is sluggish, so that shocks can persist over a longer span of time, as we will see. Another important feature of this macroeconomic textbook model is the assumption that only one type of good exists, namely GDP. We will use the shortcut Y for GDP in the following. It's typically used in all textbooks. GDP can be used for consumption as well as for investment. Consequently, the neoclassical model assumes that the transformation of consumption goods to investment goods is immediately possible. This assumption primarily helps to keep the graphical exposition of the model simple. As we will see, the Keynesian textbook model makes the same assumption for the same reason. Another quite important assumption of the neoclassical model is that GDP is produced with two types of inputs only. We neglect all the other production factors that we have already discussed in chapter 2. Here we make the assumption that total GDP can be produced only with labor input and capital input. This is certainly a simplification that makes the analysis simpler and does not change the basic conclusions which we can draw from this neoclassical textbook model. Between these two production factors, a so-called normal production relationship exists. This means they are complementary as well as substitutive. Usual complementarity means that neither with capital alone nor with labor alone a production of goods is possible. It is always necessary to use both of them at the same time. Mutual substitutability means that within some limits it is nevertheless possible to substitute capital by work and work by capital. This table gives a couple of examples which help to understand the meaning of different production relationships between labor and capital. One example for complete complementarity is the relationship between a technical engineer and a, let's say, industry robot. Both production factors depend on each other. The technical engineer cannot produce goods without the help of an industry robot. And to establish a production line with industry robots, a technical engineer is still needed. On the other spectrum of this table, you find complete substitutability. An ideal type example for such a relationship is a low-skilled assembly line worker and an industry robot. Because an industry robot can today substitute a low-skilled assembly line worker and vice versa. An example for incomplete complementarity, which is of course the same as incomplete substitutability, is a skilled engineering worker and an industry robot. Because a skilled engineering worker is typically needed to supervise and maintain industry robots. But more and more industry robots can today use, for example, artificial intelligence algorithms to do the work of skilled engineering workers. So this is an in-between area where both of the ideal type of production relationships come together. From an empirical point of view, complementarity is prevalent within the service sector, while classical industries mostly display substitutability between labor and capital. However, most industries have a strong demand for intermediary goods from the service sector. Therefore, an increase in industrial machinery investment typically causes an increase in the demand for labor in the service sector. Therefore, the assumption of a normal production relationship between capital and labor for the economy as a whole is still a good approximation for the real world. This diagram shows the GDP production function of the neoclassical model. Here we measure the production level of GDP on the y-axis and the labor input in terms of working hours on the x-axis. So this diagram looks a lot like the Solo-Svern model discussed in chapter 2. However, there's one important difference. Now the capital stock is kept constant. The assumption of a normal production relationship between labor and capital implies that it is not possible to produce anything without labor. So the production function starts here in the 0 point of the diagram. If we add more and more labor to the production process, the marginal productivity of labor is first relatively large, but then gets smaller and smaller. So we rely again on the assumption of decreasing marginal productivity, as we already did in the Solo-Svern model of chapter 2. If there is positive net investment such that the capital stock grows from one period to the other, the production function will shift upward. So the capital stock is now a shift parameter of the production function. Labor input is a migration parameter, since we migrate along the production curve if we increase labor supply. As soon as we know the capital stock, which comes from the previous period, and labor input, we can determine the level of GDP of this economy. So if labor input would be L1, the level of GDP we can produce would be Y1 with the capital stock K1. As soon as we know the capital stock and labor input, we can determine the GDP level of this economy. But to know labor input, L1, we need to discuss demand and supply on the labor market. This is what we will do next. How is labor input determined on the labor market? Firms appear on the labor market on the demand side. The neoclassics assume that firms want to maximize their profits. Consequently, they demand an amount of labor that maximizes their profits for a given real wage rate and the given capital stock K. As a consequence, they will decrease the demand for labor if the real wage rate increases. And they will increase the demand for labor if the capital stock increases. The demand for labor equals, therefore, labor demand, this is our shortcut for labor demand, dependent on the real wage rate, which affects labor demand negatively, and the capital stock, which affects labor demand positively. As a result, if we measure the real wage rate on the y-axis and labor supply and demand on the x-axis, the labor demand curve has a negative slope. The consequence of this negative slope is, if the wage rate is relatively high, the demand for labor is relatively low. If the wage rate decreases from this level to a lower level, let's say this one, then labor demand increases from L1 to L2. So this is the consequence of the negative slope of the labor demand curve. If, however, the capital stock grows, firms need more workers to manage the larger number of machines, since we have assumed that there is to a certain degree complementarity between labor and capital. Due to this complementarity, we have to shift the labor demand curve to the right or upward. Now, let's take a look at the other side of the labor market. What determines the supply of labor by households? The neoclassics assume that households want to maximize their utility. Consequently, they supply the amount of labor that maximizes their utility for a given real wage. Therefore, households will increase the supply of labor if the real wage increases, even though more working time implies less utility from the consumption of leisure time, the higher wage income allows for a gain of utility from the consumption of more goods, which overcompensates the loss of utility from a reduced leisure time. The supply of labor therefore equals labor supply dependent on the real wage rate with a positive sign. The higher the real wage rate, the lower the consumption time consumed and the more the working time offered on the labor market. If you use again the same diagram where we measure the real wage on the y-axis and labor supply and demand on the x-axis, this labor supply curve has now a positive slope, the opposite slope as the labor demand curve. If the real wage is relatively low, then labor supply is relatively low. Households prefer then to consume more leisure time. But if the wage rate grows to a higher level, then households will consume less leisure time and supply more working time to the labor market. So labor supply grows if the wage rate grows. Of course, there are also other factors which determine the supply curve of labor. One very important factor of influence is the size of the population of the economy. Typically, a certain fraction of the population wants to work. This ratio is called the labor force participation rate. Every country has a specific labor force participation rate, which is quite stable over the course of time. For example, Germany has a labor force participation rate of about 60% of the population. France, the labor force participation rate is 56%, and in the United States of America, the labor force participation rate is about 63%. No matter how large the rate in increase in population will shift the curve to the right. Let's assume that pop 2 is larger than pop 1, then this curve, which is based on labor population size pop 1, will shift to the right if population growth, let's say from one year to the other, from pop 1 to pop 2. So, population is a typical shift parameter on the labor supply curve. If we now put labor supply and labor demand curve together, the intersection point of both curves provides us the market equilibrium wage rate, where labor demand of firms is equal to labor supply of households. As we can observe here, on a labor market with free competition on the supply and the demand side, the wage rate always equals the equilibrium wage rate, such that no unemployment is possible. If there is, however, no free competition but a collective wage bargaining by trade unions which have enough power to fix the wage rate above the market equilibrium wage rate, let's say at W star over P1, unemployment results. Unemployment is the difference between labor supply by households and labor demand by private companies. As we will see in Chapter 5, where we will discuss unemployment theories, this is the typical neoclassical explanation for unemployment. It is therefore called neoclassical unemployment. In simple terms, neoclassical unemployment means wages are too high. There are, however, also completely different explanations for unemployment, as we will see in Chapter 5. The standard assumption of the neoclassical model is, however, there is no collective bargaining but free competition on the labor market. Consequently, the real wage rate does always adjust so that labor demand equals labor supply. Therefore, in the standard neoclassical model, no unemployment results. But what is the real wage? So far I have always used this expression without closer definition. The assumption that the real wage determines labor supply and labor demand is quite important for the neoclassical model, as we will see. Let's analyze the real wage with the help of a numerical example. Let's assume that the nominal wage equals 20 euro per hour work. Let's assume that the price for goods equals 10 euro per, let's say, 1 kilogram good. Now, if we divide the nominal wage by the price level for goods, the euro dimension cancels out and we receive the information that we can buy 2 kilogram goods for 1 hour work. So the dimension of the real wage is quantity of goods which can be bought for 1 hour work. Once again, the dimension of the real wage is quantity of goods which can be bought for 1 hour of work. So this means not the amount of money paid as nominal wage counts for households and firms, but the real purchasing power of money, what money buys. Consequently, the neoclassics assume that households can not be fooled by large numbers of the nominal wage. This is also called absence of money illusion. Now we know the equilibrium amount of labor input, which is determined on the labor market. Since the capital stock is given by the previous period, we are able to determine the equilibrium value of GDP. This is shown by the following graph. This graph shows the interaction between the labor market, here in this diagram below, and GDP production, here in this diagram above. On the labor market, the equilibrium wage W1 over P1 is determined, the equilibrium wage which equilibrates labor supply and labor demand. The equilibrium quantity of labor, L1, is then inserted into the production function and yields the equilibrium level of GDP, y1. What factors determine now the equilibrium level of GDP production? We will analyze this in the following graphs. We call these two diagrams the production module of the neoclassical model. We can use the production module to analyze the consequences of, let's say, population growth on GDP. As we have already seen, a larger population typically leads to an increase of labor supply. Consequently, first, the labor supply curve shifts to the right. POP2 is larger than POP1, so we have an increase of labor supply. At the old equilibrium wage rate, W1 over P1, we have now excess supply of labor. Excess supply of labor causes a reduction in the wage rate, typically the nominal wages fall, such that the real wage over the old price level falls also. When the new equilibrium real wage rate is reached, labor supply and labor demand equal again each other. This is given here in this new intersection point. Here we find now the new equilibrium labor input. This is used to produce GDP. So we have to take this new level of labor input, go to the production function and determine how much GDP we can produce if we use this new labor supply. We observe that as a result, GDP grows. Consequently, population growth causes finally GDP growth. We can, however, not use the production module of the neoclassical model to analyze the consequences of population growth on the market for goods. As we will see when we have developed the demand module of the neoclassical model, if excess supply for goods results, this will lead to lower prices, and lower prices will cause the demand for goods to increase. We have discovered now the following causal chain between population growth and GDP growth. We start with an increase of the population. This causes, as we have seen, an increase of labor supply. This leads to a decrease of the real wage rate. This causes an increase in labor demand. This causes higher labor input in GDP production, and this causes a higher level of GDP production finally. Next, we turn to the effect of an increase in the capital stock K1 on GDP production. The standard assumption of the neoclassical model is that within a production period is typically 1 year, the capital stock is constant because current investment in capital needs to be installed first before it can become productive. Therefore, current investment enters the capital stock not in the current period, this year, but in the period afterwards, the next year, in other words. Furthermore, the usage of machines in production causes a wear out, because part of machines is always consumed in the production process. This is something we have already discussed in chapter 2. This wear out equals a certain percentage rate, the depreciation rate lambda, of the capital stock K. So the yearly wear out of period T1 is also called capital depreciation and equals the capital stock of period T times the depreciation ratio. Now, what happens if gross investment is larger as capital depreciation in period T, such that net capital investment in period T is larger than 0, such that the capital stock in the following period T plus 1 is larger than the capital stock used in the current production. The primary effect is the larger capital stock shifts the production function upward, as we've already seen. So a larger capital stock allows to produce more GDP with the same labor input L1. This increase of GDP is what we can call a primary effect. But there is also a secondary effect. Because of the complementarity between labor and capital, the higher capital stock increases the productivity of labor. Therefore, firms are willing to pay a higher wage for the same amount of labor. And therefore, labor demand curve shifts now upward or to the right. So we have two labor demand curves, one labor demand curve for the old, smaller capital stock, and one labor demand curve for the new, larger capital stock. As a consequence of this shift of the labor demand curve, excess demand for labor results at the old wage rate. This excess demand brings the wage rate now upward to the new equilibrium real wage rate, W2 over the old price level. At this higher real wage, more labor is supplied by households, so that labor input increases from L1 to L2. This additional increase of labor input causes now GDP to grow even a little bit further, as given by the primary effect. Because we increase labor input from L1 to L2, we can now produce additionally a little bit more GDP. This is what we call the secondary effect. We have now discovered the following causal chain between capital stock growth and GDP growth. An increase in the capital stock causes first a primary effect, an immediate increase in GDP production, and then a secondary effect, an increase of labor productivity, which shifts the labor demand curve upward, such that there is excess demand at the old wage rate. This excess demand leads to an increase in the real wage rate. This increase in the real wage rate causes an increase of labor supplied by households, and this increase in labor input, made possible by this higher labor supply, causes a higher GDP production. This causal chain reveals that the consequences of capital accumulation for the labor market. In chapter 2, we have neglected the labor market for the sake of simplicity. So we have neglected here this secondary effect. So now we have developed the production module of the neoclassical model, which explains the determinants of the supply of goods. So much for this lesson. In the next lesson we will develop the demand module of the neoclassical model.